Hello and welcome to Minerals, Rocks, and Fossil Talks. I'm your geology teacher, Jen, and it's time for Throwback Thursday. This is Eilert Michalek. See, I told you I'd learn his name for the next video. He was born on January 7th, 1794 in Lower Saxony, Germany, to a local pastor. He first started studying languages so that he could join the embassy Napoleon Bonaparte was setting up in Persia. However, Napoleon's abdication put that to an abrupt end, so he began to pursue medicine, specifically chemistry. He moved to Berlin, where he began to study phosphates, phosphites, arsenates, and arsenites. Through these studies, he observed that corresponding phosphates and arsenates crystallize in the same form. From this, he came up with his hypothesis of isomorphism. Isomorphism in minerals basically means minerals with analogous formulas where the relative sizes of cations and anions are similar and crystal structure is identical or closely related. So they're very, very close and you can kind of interchange them. As he studied isomorphism in calcite, he then discovered allotropism. What is an allotrope? When chemical elements can exist in different forms in the same physical state. A good example is carbon. Graphite is carbon bonded in hexagonal sheets, right here, while diamond is a tetrahedral bond. Then to tie this back to the Carboniferous period, there is the amorphous allotrope, carbon, which makes up so many Carboniferous deposits. Woo! And I feel like I've been looking at diamond and graphite for like a month now because I'm going to be teaching it in my science classes in person, so that's fun. Just all about allotropes. Allotropes are awesome, guys. Anyway, thanks for coming to today's lesson. In fact, speaking of, we get the kiddos to build molecules, so I was testing out our carbons here. So right up here, boop, that's diamond. That is graphite. We're going to have the kids build them. It'll be lots of fun. Anyway, thanks for coming to today's lesson, everyone. Make sure you tune in tomorrow to learn more about Euromungandr, an early reptiliomorpha tetrapod. I'm getting so tongue-tied today. Time for a nap, and it's still morning. All right, I will fossilize you later.